Hi, hello, this is your Lucky sir. Thermodynamics, numericals type of questions. Okay, numericals, worksheet 2. We'll try to check few questions. See, which statement is correct? Which statement is correct? This is given at P, this is given at V, this is nothing but delta H, this is Cp, this is Cv is equals Cp minus Cv is equal to R, right now? Delta H by delta T at constant pressure is Cp. Delta U by delta T at constant volume is Cv. Okay, this dou is small change, delta is big change, and that is the only difference. Cp minus Cv is equal to R means Cp is always greater than Cv. So this is also right. And delta H by delta V for T. Ideal gas is 0. We were discussing about this at constant temperature. When delta T is equals to 0, internal energy is 0. Why internal energy is 0? Because kinetic energy is 0. Half mv square 0, because temperature directly proportional to kinetic energy directly proportional to internal energy. So all this. For a gas having molar mass m, specific heat at constant pressure can be given as. So he is asking molar mass m. Okay, na? And the data specific heat at constant pressure means he is asking Cp. Cp relation. We know Cp relation, I made it here already. See, Cp minus Cv is equal to R by m for 1 mole. But we know Cp by Cv is gamma, Poisson's ratio. So you can write Cv is equal to Cp by gamma. This if you are substituting here Cp in place of Cv, we are writing Cp by gamma. Cp minus Cp by gamma is equal to R by m. By simply simplifying this, you will get Cp is equal to gamma R by m into gamma minus 1. One question you can expect in your exams. Fine. Thermodynamics assignment we are doing. Molar heat capacity of water in equilibrium with the ice at constant pressure. Molar heat capacity. Okay, now molar heat capacity means again the similar formula we are going to use like this by delta T. And when something is at equilibrium, water and ice, equilibrium means delta T is going to be 0. Delta T when it is 0, something by 0 is infinity. Molar heat capacity of water in equilibrium with the ice at constant pressure is infinity. The reason is equilibrium means delta T is equal to 0. When delta T is equal to 0, that will be infinity. Something by 0 is infinity. Delta E by delta T type. Heat of formation and combustion. N2 plus 3H2 gives rise to 2 ammonia. Delta H is equals to minus 46. From the above reaction, heat of formation of ammonia. Heat of formation must be for 1 mole of compound. Okay, now how many moles are formed here? 2 moles. For 2 moles, if it is 46, for 1 mole, it will be minus 23. So, minus 23 kilocalories is the answer. Given that half S8 plus 6O2, 4SO3, delta H naught is equals to minus 1590 kilojoules per mole. The standard enthalpy of formation of SO3. Again, enthalpy of formation means it must be for 1 mole only. How many moles we got here? 4 moles. For 4 moles, if it is 1590, for 1 mole, how much it is going to be? Approximately, you take it as 1600. Okay, now use your common sense. Okay, 1590 means almost 1600. For 4 moles, if it is 1600, for 1 moles, it will be around 400. Okay, now, and the energy must be released because it is minus. So, minus 400 option is here. There is no need to go with exact calculation because minus 397.5, minus 397.97.25, such kind of options won't be there. This is not a NEET 2022. Okay, I think you remember NEET 2022 paper. 2 options were given, 0.2 difference, 0.1 difference only, 0.2, 0.3. Atomic structure, first frequency wavelength question, that question. two options. Not acceptable options actually. Okay. So this is your Lakshma Reddy sir. We are discussing thermodynamics. The amount of heat evolved on combustion of 10 grams of benzoic acid is 10 kilocalories. For 10 grams, if it is 10 kilocalories, he is asking heat of combustion. Heat of combustion must be for 1 mole. What is benzoic acid? Benzoic acid is benzene with COOH. Benzene with COOH means the formula will be C6H5COOH. C6H5COOH. Molecular mass, if you calculate, it will come 122 gram. For 122 gram, how much of energy we are going to get? For 10 grams, if you are getting 10 kilocalories, for 122, you will be getting 122. And heat of combustion is always exothermic. Must be negative. 122 negative. Heat of combustion of ethene, C2H4, is minus 337 kilocalories. If 5.6 liters of O2 is used at STP in the combustion, heat liberated is ethene, C2H4 plus O2 gives rise to 2CO2 plus 2H2. Number of oxygens 2 to the 4 plus 2 6, so we have written here 3. That means if you are taking 1 mole of this, you will be getting there, you will be in need of 3 moles of oxygen. Okay, so 1 mole of ethene, when you are combusting, you are getting there minus 337, correct? That means 3 moles of O2 will be giving you 337. 3 moles of O2 means 3 into 22.4 liters of oxygen gives minus 337 kilocalories. If it is give 5.6 liters gives you how much? 5.6 liters into minus 337 by 3 into 22.4. Do you know 5.6 table? If not, learn now. Simple. 5.6 one time, 5.6 4 times. So this is nothing but minus 337 by 12. Okay. 12 3s are 36. So 12 2s are approximately 360. And 12 3s are, if you take 360, approximately 360 it is there. So below 30, something around 30, something around 30, something around 30. Use common sense. Common sense. There is no need to use calculator. Human body requires 2370 kilocalories of energy daily. The heat of combustion of glucose is minus 790 kilocalories per mole. The amount of glucose required for daily consumption is, okay, 2370 kilocalories of energy daily. Okay, now that heat of combustion is coming from minus 790 kilocalories per mole. Okay, the amount of glucose required for daily consumption is asking in terms of grams. Glucose molecular mass is 180. Molecular mass means 1 mole, and 1 mole whatever the energy gives, that is only called heat of combustion. So 180 grams of glucose gives minus 790 kilocalories of energy. And how much we need? 2370. So 2370, if you want this much of energy, how many grams are required? 2370 into 180 by 790. Do you know 790 table? 790 one time, 790 three times. Right? Take 8 table. 790 means you take approximately 800. 800 ones are 8 is 24, 2400. So it is 3 times. And 18 table is known to you. Okay, now 18 to the 36, 83 is 54. 540 grams. Most of the times you can answer majority questions. Most of the times you can answer majority questions by using simple common sense. And chemistry teachers, they don't try to test your mathematics skills. Okay. The heats of combustion of ethane, and acetylene minus 341, minus 330 and minus 310.9 kilocalories per mole respectively. The best fuel among them is. Here we need some common sense. When you go to any petrol bunk, you are going to buy petrol in terms of liters. If you are going to any shop like supermarket, you are going to buy the oils in terms of kilograms. Okay, so kilograms are liters we buy, but not in moles. Okay, now. Okay, moles are not used generally, so we need to convert this into grams. So for ethane, minus 341 means just divide it using 30. 330 divided using ethene means 28. Acetylene molecular mass is 22. If you divide by the respective molecular masses, you are getting whatever the energy you are getting, that is per gram. Yes, this is the right way of saying per gram, per gram, per gram. In that per grams, if you see, this will come maximum. You can check because these values are very close and we are dividing with very close values. This is 26, sorry. Ethene is 20, acetylene is 26, very sorry, extremely sorry. So that will come this. Fine, one more question we'll discuss in this session. That is, the heat of combustion of benzene at 27 degrees Celsius is found by bomb calorimeter. जब भी आप bomb calorimeter देखोगे, whenever you look at bomb calorimeter, మీరు ఎప్పుడైతే bomb calorimeter చూస్తారో, you are doing calculation related to delta E. You are solving delta E. For the reaction, something is mentioned here. Value is mentioned. This is the delta E value. The heat evolved on burning 39 grams of benzene in an open vessel is. Open vessel, when he is saying, he is asking you delta H. The relation is delta H is equals to delta E plus delta nRT. Delta H is equals. It is Sunday. In our apartments, kids are enjoying, I think. Delta H is equals to delta E plus delta nRT. Done. So, delta H given, asking delta E is given 780 plus delta nRT. See, this is liquid given here. This is 1 gas. This is 7.5 gas. This is again liquid. So 6 moles of products minus 7.5 means 7.5 is equal to minus 1.5. Minus 1.5. R value kilocal is 2 into 10 to the power of minus 3. Temperature is mentioned 27 degrees Celsius means 300 kelvins. So it will be 780 plus minus 1. If you make it 0.3, this is cancelled. 0.3 into 2.6, 2.6, 2 into 3.6, 0.6 into 1.5. Minus 1.5 into 0.6. Correct? So it will come 0.45. Am I right? The 1.53. So this will come 0.9. 780 minus 0.9. And moreover, I forgot to say one thing. Delta E. Okay, now bomb calorimeter means we are burning something. Heat of combustion is always negative. So this is minus, minus, minus. So minus 780.9 kilocalories. You can see this option. Okay, but the problem is this is per mole. And what is asking for? 39 grams. Per mole means 78 grams of benzene gives this much of energy. So 39 grams, exactly half of this will be half of this. 780.9 by 2 is 390.45. First, you are calculating delta H using the formula delta E plus delta nRT. Rest all known to you. Done? Chalo, milte. Try to share with your friends because nothing special. We want to be useful for everyone. Thermodynamics is very interesting topic. Okay, now ask your friends to learn all this. If any doubts, you just message me. You know my number very well. This is my number. चलो मिलते हैं नेक्स्ट वीडियो में.